Good day, sir and everyone. In this video presentation, the topic that I'm going to present is all about hierarchical clustering. Before I start my presentation, I would like to introduce myself first. I'm Gay Diego, PSIT4C. I will discuss about hierarchical clustering analysis. What is hierarchical clustering? Hierarchical clustering is often associated with heat maps. If you're not already familiar about heat maps, is known as the column represent different sample and that rows represent measurement from different genes. Hierarchical clustering orders the rows or the columns based on similarities. This make it easy to correlation in the data. For example, this example express the same genes and these genes behave to the same. So, in hierarchical clustering, builds clusters step by step. Usually, bottom-up strategy is applied by the first considering each data object as separated cluster and then step by step joining cluster together that are close to each other. This what we call the agglomerative hierarchical clustering. In contrast to agglomerative hierarchical clustering, start with the whole and then we have an example here. So we have a leader, a manager, team leader, and employee. So this is what we call cluster. So in leader we have a grandparent, and the manager we have a parent, and the team leader we have a child. That's what we call cluster. So in this hierarchical clustering, we have a group that data into tree of cluster using dendrogram. So you are already classifying the data in hierarchical clustering. So that you can going to use tree structure in hierarchical. Then in dendrogram we have sequences of all merges and splits. Then the structure in order to represent the hierarchical clustering, the group data into a cluster in that structure are using the dendrogram. In dendrogram we have a sequences of all merges split when you're splitting the data and merging the data. So we have two methods. In hierarchical clustering, we have agglomerative and divisive method. So in agglomerative method, we have a bottom-up method so in agglomerative method is from the bottom to top. Then calculate of the cluster with respect all of the other cluster. Then consider every data point as individual data. Merge the cluster with highest similarities. Recalculate similarities for each cluster. Now repeat step 3 and 4 until single cluster is obtained. So this is the dendrogram example. We have A and B. So A and B, if I'm going to merge them, so we have A, B. And then the same at the C and D. So we are going to merge them and we have make a cluster, one cluster, and E have one cluster. So C, D, and E, C, D, E. Then the line of merging is going to up. In dendrogram, AB and CD. So AB and CD are the high similarities of the cluster. So that what we call is A, B, C, D, and D in dendrogram result. A and B, we have to calculate the similarity of A and B. Now, we have a 3 modes. In the single linkage mode, we have a minimum, the complete linkage with a maximum, and the average linkage, we have an average. The divisive method with the splitting of the data from the top to bottom in this cluster have A, B, C, D, we have the data items. So, in this, what we call the similarity. Using the 3 modes. Next, A, B, C, D. Now we have our next. We are going to the divisive method with splitting. The divisive method is divising cluster is the opposite of algorithm clustering. We take the data items a single cluster. In iteration, we split the data. At the end, we get in cluster. So, in this splitting data in divisive method, we have cluster have A, B, C, D, and E. So, in divisive clustering is the opposite algorithm clustering. So, there are some example of A, B, C, D, and D in divisive clustering when splitting the data. We have A, B, C, D, E. In A, B, we have to split the 2 letters, and at the same time, we have split the letters at the right side. So, the line we are going to top down. Then, what we call this cluster splitting the data or splitting. According to the Euclidean, distance and similarities between data observation and the next iteration, the whole single set is divided into multiple clusters, hence the name divisive. This same process continues until the achieve the maximum those values.